Dear students, welcome to the new episode, and in this episode I'm going to solve topic questions which are about organic chemistry. In this episode we are going to solve question number 5 from year 2016, May-June series, paper 42. And also I'm going to solve question number 6, year 2016, May-June series, paper 41, and question number 7, 2016, March, actually series this February, March, and paper number 2. So let's start with the first question, which is question number 5. Here we have hydrocarbons. Hydrocarbons are compounds with, which contains hydrogen and carbon. 10 cubic centimeter of this hydrocarbon bond with 100 cubic centimeter of oxygen. Combustion reaction, which is an excess. So this oxygen is in excess. That means more than that we need it. Okay, more than that we need it. After cooling to room temperature, that means after the end, that means after the reaction, we have cooled to the room temperature and pressure. There is a 25 unreacted oxygen. You have started with 100. And you have ended with 25 cubic centimeter. That means not all the oxygen has been reacted, only 75 cubic centimeter. And you have formed 50 cubic centimeter of carbon dioxide, which is one of the products of the combustion reaction, and liquid water. Now, what's meant by an excess of oxygen? As I told you, more than enough to react. More than enough to react. Why it's more than enough? Because you have started with 100 and you have ended with 25. That means the amount of oxygen that we needed, it's only 75, but we have started with 100, more than enough to react. What was the volume of oxygen that reacted with hydrocarbon? It's only 75. How? Because you started with 100 and the rest is it's 25. So only 75 cubic centimeter of oxygen has been reacted. So then you have a table to complete the table to express the smallest whole number ratio. Smallest whole, that means we don't need fractions, number ratio of these volumes. So here in this one you have a volume of hydrocarbon reacted, volume of hydrocarbon which is reacted, which is 10 cubic centimeter, and volume of oxygen reacted, it's 75. And volume of carbon dioxide, it's 50. Okay, so then we are going to divide these numbers over the smallest number. That means here over 10, over 10, over 10. This one it will give us 1, this one 77.5, and this one is 5. Now, yes, this is the whole the smallest ratio, actually smallest ratio, but is it whole number? No, because here we have 7.5. so to make it whole number, that means you need to make this 7.5 whole number. How? By multiplying it by 2. So if you will multiply this one 2, that means all these numbers should be multiplied by 2. So this one it will be 2, and this one it will be 15, and this one it will be 10. So this is the smallest ratio with the whole numbers. Use your answer to IIII to find the mole ratio in the equation below. Complete the equation and deduce the formula of the hydrocarbon. So here you have 2, and from oxygen you have 15, and from carbon dioxide you have 10. Okay, now then we will find the hydrogen. Now, first of all, ask yourself how many carbons you have produced in the product. 10 carbons. That means this X is multiplied by 2, X multiplied by 2, and this one it's equal 10. That means what's the X? X equal 5. So this X, it's 5. Same thing for hydrogen. Same thing for hydrogen, we will calculate it at the end. Now, how many oxygen atom you have? You have 30. You have 30 oxygen atom. Here you have 20, so here we have 10. Here we have 20 oxygen atom, and here 30. So this is 20, here we need 10. So here 1, so this one should be multiplied by 10. So here you have y times 2, y times 2, y, this one, times 2. How many hydrogen you have produced? You have produced 20. So y equal what? Equal 10. 20 over 2. So this y, it's 10. So what's the formula of hydrocarbon? The formula of this hydrocarbon, C5H10. This compound, we can name it as pentene. In the question B, cracking is used to convert long chain alkanes into shorter chain alkanes and alkenes. Alkenes are unsaturated compounds. Here you have decane C10H22 can be cracked to give a propene, and one other product. So here we have decane, and this one it's propene. So this is the long chain alkane, and this is the alkene. The rest is the shorter chain alkanes, which is you need to subtract this compound from whole compound. So you have C7 and with the H16, which is heptane. This compound is heptane. Okay, now let's start with the next question. What's meant by the term unsaturated? Unsaturated compound contains carbon-carbon double bond or carbon-carbon triple bond. These are unsaturated compounds. So describe a test to show that propene, which is alkene, is an unsaturated compound. The test is bromine water. Bromine water or bromine solution. The result, the color of bromine, it will be decolorized from orange or yellow to colorless. And in this question, here we have propane can be polymerized the only product is polypropene. The equation for the polymerization is shown here. Name the polymerization that occurs. Because you started with propene, which is double bond, and you have polypropene, so the name of this reaction is addition polymerization. Deduce the maximum mass of polypropene that could be produced from 1 kilogram of propene. So here in this in the addition reaction, you don't have byproduct. All the reactants are converted into one product, one reactant to one product. So if you started with 1 kilogram, that means you need to end it with 1 kilogram. So here only 1. Empirical formula, so you have C3H6, that means the empirical formula for propene is CH2, and here in the polymer also you have 3 carbons with 6 hydrogens, so CH2. Always in the addition polymerization, both of the empirical formula of monomer and polymer are. Question number 6. You have petroleum, which is a crude oil, is a source of many important chemicals. Name 2 industrial processes which must take place to produce alkenes, not alkane, alkenes from petroleum. So first of all, here petroleum. You have to make fractional distillation to obtain alkane, and from alkane you are going to do cracking to get alkene. And in the next question, ethene and propene can both be converted into polymers. What type of polymerization take place when ethene forms a polymer? This question is the same the previous one. Here you have alkene is converted into polyalkene, which is the name of the polymerization. It's addition polymerization. Empirical formula of polymer named from ethene. Also, as I told you, always in the alkene and their polymer, the empirical formula are the same. So here ethene, you have 2 carbons and 4 hydrogens, so it's CH2, the empirical formula. And propene has the structural formula, this one. Draw 2 repeat units of the polymer. So start to draw first of all propene. Here start with the double bond first of all, and here this is CH3. Draw it to be similar to the ethene. Here hydrogen, hydrogen, hydrogen. The polymer, the same monomer without double bond, with single bond. So this is one CH3, H, H, and here there is a double bond between these 2 carbons are broken down, and you have formed here 1 repeat unit. Actually the second repeat unit totally similar to this part. So here another one should be connected. Here CH3, here H, H, H. So here we have 2 repeat units. In the next question, you have here ethene will react with steam to form ethanol, but propene will react with steam to form 2 isomers, 2 different alcohols. suggest the structure of these alcohols. Again, let's draw the propene. This is a propane plus H2O. This H2O, we can write it like this one. So this H could be added to this carbon or could be to add to this carbon. So you have two options. Same thing for the hydroxide. This group could be added here or could be added to this carbon. So you have two options. So let's start with the first option. Here, this one, CH3, H, we break the double bond. So the first option, we have added here the hydrogen and OH here. The second isomer, same compound, just you need to inverse the position of H and OH. So OH here it will be, and here H. So the position of the OH here in carbon number 2, but the position of OH here it's in the carbon number 1. So the first one it's 2-propanol. 2-propanol. Sorry, just there is propanol. And the first one, because the hydroxyl group here is bonded to the first carbon, so it will be 1-propanol. So these are both of them are isomers. Why? Because they have same chemical formula, but they have different displayed formula, the position of OH. Esters are organic chemicals noted for their characteristic smells. Ethanoic acid and methanol will react to form an ester. But here in the question number 1, they are asking about the catalyst. Always in the esterification to form ester, you need to use some drops of concentrated H2SO4. And name the ester formed when ethanoic acid reacts with methanol. From methanol, you will have methyl. And from ethanoic acid, you will have ethanoate. Ethanoate. So the name of the ester, methyl ethanoate. Draw the structure of the ester formed when ethanoic acid reacts with methanol. So he is asking about only the ester. So, but I need to explain the ethanoic acid, methanol, then we will draw the product. So ethanoic acid, 2 carbons, 1, 2. The functional group in the ethanoic acid, it's C double bond O, OH. And here you have hydrogen. This one, ethanoic acid plus methanol, you have 1 carbon, and OH, and here you have 3 hydrogen. And sulfuric acid, which is ester, the catalyst of the esterification. So what's the ester here? Always you need to remove hydrogen from alcohol and OH from carboxylic acid. So what the result it will be? The result here, again, CH3. I'm starting from this carbon, then carbon, double bond oxygen. You have removed the OH and you have removed this H. So this carbonyl it will be bonded to this O. So here we have O and again CH3. So this is methyl ethanoate. So we have draw the structure, show all the bonds. We have shown all the bonds between the atoms. The common name of this ester, it's little bit this question. You need to memorize the common name of these polymers, and the name of this polymer is called terylene. Sorry. The common name of this one is terylene, and the systematic name, which is methyl, we said methyl ethanoate. Next question, which is the last question here, the question about alkane and alkene. So alkanes and alkenes are example of hydrocarbons. Here, what's meant by the term hydrocarbons? So it's organic compound contains only hydrogen and carbon. The general formula of alkane, it's CnH2n plus 2, and for alkenes it's CnH2n. Here we have another question about the empirical formula. So you have compound which is X contain this percentage of carbon and this percentage of hydrogen and this percentage of oxygen. So carbon is 54.54. Convert all these percentage into gram, just write the gram. Here you have hydrogen, it's 909 gram, and oxygen 36.37 gram. Then convert them into their mole, so over 12 over 1 over 16, and this one it will give us these results. This one it will be 4.5, and the other it will be 9.9, and this one it will be 2.27. Then you will divide this number of moles over the smallest number, which is this one, 2.27, 2.27. This one it will give you 1. And this one it will give you 4, and this one it will give you exactly 2. So your compound contains 2 carbon with 4 hydrogen and with 1 oxygen. So this is the empirical formula. And then here in this question, so let me remove this part here. Compound X has a relative molecular mass of 88. Deduce the molecular formula of compound X. So here you need to use this equation. So let me write the empirical formula in this part. We told it it's C2H4O. Okay, so you need to calculate the number of empirical formula. Number of empirical formula, which is equal mass of X over mass of empirical formula. The mass of X, which is 88, and the molecular mass of this empirical formula, you have 2 carbons, so 24, and 4 hydrogen, it's 4, and with 1 oxygen, which is 16. So here you have equal 44. So you have here 44, the mass of empirical formula, 44. So that means your compound. So the mass of empirical formula is 44, and this one it will give us 2. That means your compound contains 2 empirical formula. What are these 2 empirical formula? C2H4O. That means you need to say 2 times C2H4O, and this one it will give us C4H8O2. So this compound could be carboxylic acid or ester, because only these 2 compounds which contains 2 oxygen atoms for your level. So here you have ester. Why? Because you have 2 oxygen atoms, so it's ester. So name and give the structural formula of 2 esters with this molecular formula. So this ester could be formed from carboxylic acid and alcohol, but this alcohol could be, let's write it here, explain it, could be here carboxylic acid, let's say, and here we have alcohol. You may start here with alcohol with 1 carbon, which is methanol, but here you need to start with carboxylic acid with 2 carbon. Why? To have summation 3 carbons. Or you can start with 1 carbon from carboxylic acid with 2 carbon of alcohol. So if you will start with 2 carboxylic acid with 1 alcohol, that means the ester it will be methyl ethanoate. But if you will start with 2 alcohol with 1 carboxylic acid, that means the number of carbons, you will say it's ethyl methanoate. Methanoate. The structure, so you need to start with this one, ethanoic acid, the part of the ethanoic acid. So here you have CH3, COO, CH3. But for this one, you need to start with HCOOCH2CH3. So this part comes from ethanol, and this part it comes from methanoic acid, and this part it comes from methanol, and this one comes from ethanoic acid. Name the ester produced from the reaction of propanoic acid with methanol. The name of the ester, which is methyl, which it comes from alcohol, and propanoate, which it comes from propanoic acid. And here you have polyester is represented by the structure here. You have here and here. Sorry. This one. What type of polymerization is used for production of polyester? The name of it's called condensation reaction or polymerization. Always in the condensation you are going to remove very small molecule, which is H2O. And to represent this one, you may see here, this is carboxylic acid. Here, complete the diagram below to show this monomer. So here, carboxylic acid, and this one, HH. The name of this one, it's dicarboxylic acid, and this one it's called diol. That means dialcohol. So by the end of this question, we have completed this past paper, and you may see in the attachment the mark scheme also, which is you may download it with one PDF in the attachment of this video. So see you in the next episode with a new past paper with the new questions. See you again.